Hello everyone. This video is a quick intro to quadratics in the real world. We're told that the following graph represents the height of a diver. We have 4 questions that we're asked to use the graph to answer. So let's get right into looking at our first question. It says, circle where the diver would hit the water or the ground. So I'm going to take a second, and I would like you to try circling where you think that happens. And of course, we are writing in pencil. So if we circle something that needs to get erased, it will be okay. So I see here that my y-axis represents the height in meters, and time is on the x-axis. So if I'm talking about where the diver hits the ground, ground is at a height of 0. So height of 0, and I look and I look and I look, and that happens right here. So we've successfully circled where the diver hits the water or the ground, and now it says this would be finding the x values when y equals 0, because again, 0 represented the height. Remember our general form of a quadratic, so quadratic function in general is ax squared plus bx plus c, and we could write f of x equals, use f of x to represent y. So in this situation, if we're setting y equal to 0, that would look like 0 equals whatever that function is. So if we ever see in a question, when does the diver hit the water, or when does somebody, or something, excuse me, when does like a rocket hit the ground, we will always be setting that equation equal to 0. Number 2 says, place an x where the diver reaches their highest point. So go ahead with a pencil and place an x where the diver reaches the highest point, and then we'll see if we match. When I look at this graph, I see that his height's increasing. Right here, he hits a maximum height, and then now his height is decreasing. So the x marks the spot right at that highest point. That highest point is called the vertex. So when it says place an x where the diver reaches the highest point, this would be finding the vertex. We find the vertex using a neat little formula. Looks like this. xv equals negative b divided by 2a. That a and b directly come from, see if I can fit it on the same, a and b, right from the equation that you have. And then this notation, xv, means the shorthand way of saying x value of the vertex. But instead of having to write that all the time, x value of the vertex equals, we just say x with this little subscript v, and then we automatically know, oh, that's talking about x value of the vertex. But we know that an ordered pair is 2 points, x comma y. So to find the y value of the vertex, once you have your x value, you will plug in the x value of the vertex. Plug in x value of vertex to find y. Number 3, put a box where the diver would reach a height of 29 meters. So as soon as I see that I'm given a height, I ask myself, is that a value for x or a value for y? And when I go look at the labels, it's definitely not going to be x, because check it out. The x-axis is all about time. My y-axis is all about height. So that is a value for y. So let's go look for 29 on the y-axis. 22, 23, 24, 25, 26, 27, 28, 29. And then I look at 29 and I say, well, he's going to be at a height of 29 right here. But if I keep looking, he's going to hit that height again. Which makes sense, because if the diver reaches that height on the way up, at some point, he's going to start coming back down. So we will end up having 2 answers. Height of 29 meters at 2 times. And again, that's once on the way up, and then what goes up must come down, so again on the way down. So the diver reaching a height of 29 meters, that would be substituting $29 in for y. So it would look like 29 equals whatever the quadratic is. Last but not least, number 4 says, put a triangle where the diver begins. So let's go look and see if we can find where the diver starts. Take a second and see where you would put a triangle, and we'll see if we match. Well, if he's beginning, it means no time has gone by. So at 0 seconds, I look, and here, I should make that blue. Let's go purple. This is his starting height. His initial height. So this would be the initial height. Ask yourself, when x equals 0, what's y? And you could calculate that by finding f of 0. Or, so calculate f of 0. Or if you have a graph, look for the y-intercept. So take a second to look at the big picture. Over the next couple of days, we will actually be practicing all of these parts. So if we're asked, I'm going to take out a highlighter, so if you want to pause the video, press the space bar, pause, and go grab a highlighter. If I'm asked to find when something or someone hits the water or the ground, we are setting the quadratic equal to 0. If I'm asked for the highest points, we're finding our vertex. The key vocabulary word you will hear often. And we do that using this formula. xv equals negative b divided by 2a. For 3, I'm not actually going to highlight anything because that value for y could change. But notice, just like for the water or the ground, we're saying set it equal to 0. So we actually set our function equal to 0. This is saying, well, now I'm not setting it equal to 0. I'm going to set it equal to 29. And that's why 29 was substituted in for the y value. Last but not least, where a diver begins, That's your initial height. So you can calculate f of 0, plug in 0 for x, or look at your y-intercept. That wraps up this quick notes video to get us ready for our real-world falling object scenarios, which will start tomorrow. Have a great day. I will see you guys soon.